Hi, everyone, and wonderful timing from the sirens outside my apartment. Hi, welcome to the Planetarium live stream. My name is Jessica. I am the director of the Planetarium, and with me tonight is one of the students that works there, and I'll let him introduce himself.
Hi, my name is Eli. I'm a physics and astronomy undergraduate student at UMD.
So tonight we are going to be taking you all on a tour of our solar system. We've got lots of cool things to visit in not that much time, so we want to make sure that we hit the places that you are interested in seeing. So if there's any planet or even moon that you're really interested in seeing and hearing about, leave it down in the comments, and Eli will keep in touch with me as I am navigating our spaceship so that we can go to all of these places that everyone wants to see. But with that, I'm going to get switched over to our spaceship view. So to take our tour of the solar system tonight, we are going to be using a program called Stellarium. Not Stellarium, Celestia, sorry. Celestia is another really awesome free program that you can download for yourself and navigate through the universe all on your own. And tonight we are going to start with our very own sun. But we are looking at. I just saw my mom's comment. I will go to Pluto, Mom, I promise. We are starting off kind of in the middle of space right now, and you may notice or not notice that our sun is somewhere in all of these stars. Um, from this far out among all of the stars in our galaxy, it's really easy to see how our very own sun is really pretty average, like all of the other stars that we see up in the sky. It just seems special to us because we are so very close to it. But let's zoom on in. And as we make our approach, we can now see the sun in a bit more detail. And we can see the orbits of the planets, but we can't see the planets themselves. And that's just because they're so small that we really can't see them unless you're super up close. But as we continue our way in through the outer planets that are spread pretty far apart into the inner planets that are a bit closer together and much closer to the sun, we can then make our way to the sun itself. And our model of the sun here is showing these kind of dark spots, which are known as sunspots because they're spots on the sun. Astronomers are not always clever with their names that they give to things. And these look darker because they're actually cooler spots on the sun. Now, when I say cool, I don't mean what you may think of as a cool temperature. So the sun on average is about 7,000 Kelvin, 7,000 degrees, or it's 10,000 degrees Fahrenheit. These spots are about 7,000 degrees Fahrenheit. So cooler than average, but still very, very hot. But I think that's enough of our sun. Let's start looking at some of our planets. And we're going to start with the closest planet to the sun, which is Mercury. Let me turn the orbits off, and I'll turn the labels off. And let's go in and take a close look at this. So Mercury might look pretty familiar because, well, frankly, it looks a lot like our moon. And there's a good reason for that. Mercury and our moon are two very similar objects. They're both quite small. Mercury is about a third the size of the Earth. And they are what we call geologically dead. So they don't have any earthquakes, volcanoes, anything like that. And so all you really see is just thousands and thousands of craters all over the surface because the This planet has been around for 4.6 billion years. And over that entire time frame, it's just been hit over and over and over again. And all of these craters just add up over time, over 4.6 billion years. And so that's kind of the dominant thing that we see on the surface of Mercury. Now, since Mercury is very close to the sun, it does get quite hot. Daytime temperatures can reach up to about 700 degrees Fahrenheit, but that's only in day. When you are in nighttime on Mercury, it actually gets really cold. And that's because Mercury doesn't have an atmosphere to hold on to that daytime heat and keep the nighttime warmer like we have here on Earth. Our nights don't get as cold as they would because our atmosphere holds on to some of that heat and keeps it a little bit warmer. And so the nighttime side cools off really quickly and ends up getting temperatures down to negative 200 degrees Fahrenheit. So we have a world of very extreme temperatures here, either really hot in the daytime or really cold in the nighttime. All right, so let's head on now to the second planet from the sun, which is Venus. And Venus for a while was kind of known as Earth's twin. And that's because Venus is very similar in size to the Earth. It's only slightly smaller. It's about, I think, 98% the size of the Earth. So because they are the same size, and as we can see, it's covered in clouds, a lot of people thought that maybe Venus was quite similar to the Earth. But we didn't know for sure because of these clouds. There are so many clouds all over the place, covering the entire surface, that we can't see to the ground. So it wasn't until the 1970s, 70s? Yeah, 1970s, when we sent a spacecraft that had radar on it. And that radar was able to peer through the clouds and give us our first view of the surface of Venus. And it looks something like this. Now, I do have to add that the color that you're seeing is not true color. Radar is done with radio waves, so it's not light that we can see with our eyes. And so we assign the values of the radar a false color, in this case, different hues of yellows and orange. So this isn't what the surface of Venus actually looks like. From what we can tell, the rocks on the surface are like basalts, like those dark volcanic rocks. And so the surface would actually be covered in these kind of dark gray rocks. But we can see the surface has some interesting features. We see some variations there. There are some things that look like these cracks across the surface. What we're seeing around here with these bright streaks are actually volcanic flows that have happened in the past. Venus does have a lot of volcanoes. But one thing we don't see is any liquid water, which is very abundant here on Earth. And the reason we don't see any liquid water on Venus is because it gets so very hot. Temperatures on Venus get over 800 degrees Fahrenheit. That is hotter than daytime temperatures on Mercury. Even though Venus is further from the sun, it gets hotter than Mercury. And that's because of that really thick atmosphere. That atmosphere acts like a blanket and traps heat below the clouds, raising those temperatures to extremely hot temperatures. So Venus, it turns out, is nothing like the Earth. It is a very hot, horrible place. Not just scorching temperatures, but the clouds that we do see are sulfuric acid clouds. And the pressures on the surface of Venus reach about 90 times what we experience here on the surface of the Earth. So you would melt, be dissolved, and be crushed all at the same time. Not exactly a place we really want to go visit, but it still has some interesting things. Like I said, all of those volcanoes. We're actually not sure if there are any active volcanoes. We haven't seen any active eruptions, but that doesn't mean that it's not active. There's a very, very good chance that it is. But let's move on.
Just really quick, I want to
Yeah,
note that so far we have requests to see Jupiter, Pluto, and Neptune.
awesome. Well, I will hurry through the terrestrial then, and so that we can get our way out there. So let's go take a look at the third planet from the sun, our home planet, Earth. And this is the one that we know the most about since it is the planet that we live on. Very different from the other planets in our solar system in that it is covered in liquid water. We don't see that anywhere else. It, of course, is also the only planet we know of that has life, that has us. And that's having an effect on our planet. So that really thick atmosphere that Venus has is made up of 96% carbon dioxide. Carbon dioxide is a greenhouse gas, which is why it's so good at trapping that heat and raising the temperatures of the surface of Venus. And with all of the activity that humans are doing on the surface of the Earth, we are pumping extra carbon dioxide into our atmosphere. Now, we do need a little bit because that keeps temperatures just right so that it's not too hot, not too cold. But as we're pumping more and more in, we're seeing those global temperatures go up. And Venus is a good kind of warning of what can happen when you get too much carbon dioxide in your atmosphere. So it's a very important thing for us to understand what we're doing and try and mitigate those effects that we're having. But I'm going to stop talking about that for now. And let's actually go see. I have to use my little window over here. Drag that out of the way. We're going to go see our moon. So the Earth is the first planet that we have seen that has a moon. None of the other planets so far do. Mercury and Venus do not. And our moon looks a lot like Mercury. It's also quite small, about a fourth the size of the Earth, so a little bit smaller than Mercury is, covered in those craters like we see. But unlike Mercury, the moon has these kind of dark patches, and they're a little bit hard to see at the moment. So let me speed up time so that we can get those into the daytime. Now, these dark patches that we're seeing are known as the lunar maria. Maria is Latin for sea because we thought that they were ancient seas long before we had telescopes. But these are actually old lava flows. So sometime in the very, very late or very, very early solar system, uh, the moon must have been hot enough to have some molten rock underneath the surface that when the surface got cracked open, probably by a really big impact, allowed the molten material to seep up to the surface and flood the surface, and then it cooled and hardened into these dark rocks that we see. Now, we have done a whole show all about the moon. If you're interested in learning more about that, you can always go check that out on our YouTube page or in the video section of our Facebook. But let's head on to the last of our inner terrestrial world, and that is the planet Mars, known as the red planet, because it, well, looks red. And that red color comes from rust all over the surface. And there's a couple of really cool features that I want to show you. And let me just spin those around so that we are facing them. So first off is this really big thing right here. This is actually a volcano known as Olympus Mons, the largest volcano in our solar system. In fact, it would cover up the entire state of Arizona and sits about 3 times taller than Mount Everest, a huge volcano. Now, next to it, we see a few other large volcanoes. Mars has quite a few of them, although they are not active anymore. These are all dormant volcanoes. But the other really massive thing that Mars has is this huge crack across its surface known as Valles Marineris. Always makes me want spaghetti. But this is like the Grand Canyon, except, well, grander, because this canyon would stretch across the entire United States. It is huge. All right, so let's start moving out so that we can go hit those planets that people are wanting to see, which are out in the outer solar system. What just happened? 5. There we go. Okay. I sometimes. Ooh, what is going on? What is going on? Why are you doing this? Okay. Sorry, folks. Give me 1 second. I think
I feel awkward not saying anything, but the stream is like lagged behind, so I can't see what's going on in time.
I don't know what is going on. I am not as familiar with Celestia as I am with the software that we use. So let me just try it this way. Why are you doing... Okay, give me 1 second, folks. Let me try restarting. So I'm gonna switch you over to the Zoom screen, which is not showing up for some reason. Give me 1 second.
I wish I knew astronomy jokes, but I don't have any in my back pocket. I'm trying to think.
Well, what's your favorite planet, Eli?
Um, I don't know. Earth is pretty sweet. I kind of like living here.
Fair,
But I feel like
fair,
I feel
fair.
like it's a cheap answer to use that one. So my favorite that's not Earth is probably, I don't know. Saturn's really pretty. The rings are so beautiful.
It's
Um,
true.
I'd probably have to go with Saturn. It's so cool to see it through a telescope too.
All right, I think I got it back up. I'm gonna try a slightly different window. You'll see a little bit more of my desktop, but we'll keep going. Sorry about that. All right, so we are now at Jupiter. Jupiter is the king of the planets because it is the largest planet in our solar system. It takes about 10 Earths side by side if you'd want to go across Jupiter. And it has these beautiful swirls and bands of clouds. We also have a really cool feature right over here. This big red circle is the, well, Great Red Spots. Remember, I said astronomers are not always super clever with their names. This great red spot is kind of like a hurricane, like we have here on Earth, except much, much more extreme than any hurricane we have here on Earth. This hurricane could fit anywhere from 2 to 3 Earths inside of it, depending on the year. It kind of changes size every so often, but it's much bigger than the Earth itself. And it's also been around since the mid 1600s. Basically, as long as we have been looking at Jupiter through a telescope, we have seen this giant storm. So it is incredibly long-lived, especially compared to the weeks that hurricanes last here on Earth. And we're not entirely sure why it lasts so long. One of the leading hypotheses suggests that maybe because Jupiter doesn't have any solid ground, there's no ground underneath these clouds, that maybe that's keeping the storm sustained, because we know hurricanes here on Earth lose energy when they run over ground. So maybe if there's no ground, it doesn't lose its energy. We're not sure. That's one of the many active topics of research on Jupiter, is trying to understand the storm a bit more. Let's see. The other thing that Jupiter is pretty well known for are all of its moons. And here are some of them. And let me... Sorry, folks, you're seeing some of the behind-the-scenes stuff here. There we go. Or it didn't stay. Okay, anyway. Jupiter has quite a lot of moons. It has about 79 moons. Let me... Come on, come back. There we go. 79 moons around it. Now, most of these moons are not too much to write home about. They're what we lovingly call lumpy space potatoes. And so they're really just kind of chunks of rock, things like asteroids, that got a little bit too close to Jupiter, and Jupiter's gravity just kind of held on to them. But there are a couple of really cool ones, and I want to show you two of them. So,
can I come in with a question really quick?
Absolutely.
Well, we actually got two. One of them was how long the Great Red Spot had been going on, which you touched on. But then the second one was how Jupiter got so big compared to the other planets.
Ooh, that's a good question. And that's something we're actually still trying to figure out. We know that one of the reasons Jupiter got so big is it just was in an area. So let me back up a little bit. The solar system formed from a big rotating cloud of gas and dust that collapsed into a disk of gas and dust. At the very center, our sun was forming, and the planets formed within that disk. And we think that Jupiter was at a spot that it just had a lot of material to form from. It had solid bits of rock, metal, and ice that could all stick together and grow bigger and bigger and bigger. And because there was so much material to grow Jupiter from, it actually got so big that it could pull in gas. Instead of having to grow from just solid bits, it could actually pull in hydrogen and helium gas, which allowed it to grow even bigger, even faster, because there was just so much of that stuff around. But why it got bigger than, say, Saturn or the other outer planets, we aren't entirely sure. And that's another active area of research, is better understanding how these really big Jupiter-sized planets can form and why Jupiter was the one that got so big. That's a great question.
Yeah, and then as for the other one, I'm sorry, I don't remember if you threw out the number of how long it's been there, but I know you mentioned we saw it in the 1600s, so at least 400 years.
Yeah, at least 400 years. The Great Red Spot has been around. All right, so one of Jupiter's moons that I want to show you is this guy right here. His name is Io, but we like to call him the pizza moon because he, well, kind of looks like pizza, right? He's got that cheese and sauce, and I say sausages. Eli says olives. If you've seen one of our shows, you've heard us argue over this in the past. But what's really cool about Io is all of these dark spots that you're seeing are actually volcanoes. Io has over 150 active volcanoes on its surface. That's way more than Earth has, and more than anything else in our solar system. It is the most volcanically active object in our solar system. And that's actually strange, because Io is about the same size as our moon. But our moon doesn't have any active volcanoes, so why does Io have so much? And it turns out that that is because of Jupiter over there. You see, Jupiter and its gravity is constantly tugging Io towards it. But then on the other side, we have all of the other moons around Jupiter that are tugging Io the other way. And so Io's getting tugged back and forth. And as it's being tugged back and forth, it's being kind of squeezed and stretched in different directions. And that squeezing and stretching causes the interior, the rocks inside of Io, to rub against each other. And just like when you want to warm up your hands on a cold day, as those rocks rub against each other, they heat up. And it's being stretched and tugged so much that it's just being heated up an incredible amount. And the only way for all of that heat to be released and escape is in the form of all of these active volcanoes. So Io is quite an interesting little world. But the other one that I want to take you to is Europa. So Europa doesn't look like much on the surface. In fact, its surface is really just a layer of ice, and you can see some cracks in that ice. But what's really interesting is what lies beneath that shell of ice, because underneath that is what we think a huge ocean of liquid water. In fact, we think the ocean of Europa is bigger and contains more water than we have combined here on Earth. And this is really exciting for astronomers because one of the things that we think life needs in order to develop is liquid water. And so if we have a huge ocean of liquid water, there's a chance there's life there. And so there's actually missions being planned to travel to Europa and try and explore that ocean and see if any life has in fact developed there. And I'm very excited for this to happen. I hope it happens in my lifetime because I would really, really love to find little alien fishies swimming in Europa's ocean. It would just be really cool. All right. So let's say goodbye to Jupiter and head on over to our next planet, the planet Saturn, the one with the beautiful rings. It's always what it's known for, is that ring system. Although it's actually not the only planet to have them. Jupiter, Saturn, Uranus, and Neptune all have rings. It's just Saturn's are the biggest and brightest, and so we can see them easily through a telescope here on Earth. So they were the first ones discovered, and they're the ones that it's the planet that's best known for them for that reason. We can see that Saturn also has these kind of stripes of different colored clouds, just like Jupiter does. And of course, surrounded by a giant ring system. These rings are not solid, though. They're actually made up of millions and millions of little pieces of ice. And each of those little pieces of ice just orbits around Saturn. We're not entirely sure where all of this ring material came from. It's very likely that some of this is pieces of moons that's been knocked off as those moons have been hit by things. It could also be a moon that got a little bit too close to Saturn and Saturn's gravity ripped it apart. Or it could even be a comet that got too close to Saturn and Saturn's gravity ripped it apart. All of these are very likely very good options to form this beautiful ring system. But one thing I also want to show is how thin the rings are. So these rings, if we try and look at them edge on, are like paper thin, which is crazy, but that's why looking through a telescope here on Earth, we may not always see the rings if we're seeing it edge on, and it's because of this. All right, let's take you to, oh, we're getting low on time. Actually, you know what, let's head on because I know we had other planets. So let's head on now to the next planet, which is the one with the funny name, Uranus. Now, my favorite fact to tell about the planet Uranus is that its name actually used to be George. It was named for King George because the astronomer William Herschel is the one who discovered this planet. And he wanted to name it after the king because he knew that would make the king happy and the king would then give him lots of money. And that's exactly what he did. But the other astronomers weren't happy about this new planet being named after an English king, especially the non-English astronomers. So after years of arguing and debating, they ended up renaming it Uranus, which is one of the Greek gods, and so it keeps the pattern of the planets being named after Greek and Roman gods. We have this really pretty kind of bluish green color to it, which actually comes from methane in its atmosphere. Methane absorbs red light and reflects blue light. Let's see if I can speed up time a little bit here. You can kind of tell that Uranus actually spins kind of like a wheel. It's been knocked over on its side. And that's actually what we think happened. We think a really big collision just hit the planet and knocked it over on its side. All right, let's go see Neptune. Neptune is another gorgeous planet to look at. That really pretty blue color we see also comes from methane, just like Uranus's atmosphere. We do see more features, though, here than we see in Uranus's atmosphere. We see some really high kind of white clouds. We also see a dark spot that looks a lot like Jupiter's Great Red Spot. It's known as the Great Dark Spot, telling you, super clever with names, these astronomers. But it is, we think, a storm similar to the Great Red Spot. The difference, though, is this one seems to have disappeared. It doesn't seem to have lasted for as long as Jupiter's Great Red Spot. We're not entirely sure if it's completely disappeared. It could just be there were some higher clouds that have kind of covered up our view of it. But the last few times we got some good close-up looks, we haven't seen that storm there. Unfortunately, with Uranus and Neptune, we don't have a lot of information. They're difficult for us to study from here on Earth because they're so far away. And we've only had one spacecraft that flew by close to them, and that was Voyager 2 back in the 1980s. So there is a lot that we don't know about them simply because they're difficult for us to study. One of the really cool things, though, we think might be going on inside of Uranus and Neptune is the temperatures and pressures might be just right to scrunch up the carbon in the atmosphere into actual diamonds. And those diamonds would fall as rain. And so we think that Uranus and Neptune might rain diamonds, which is just really freaking cool. All right, Mom, you wanted to see Pluto. Let's go see Pluto. I think I have to... Oh, no, I can do it from here. All right, so the version of Pluto in this program unfortunately hasn't been updated since the New Horizons mission. And I tried to download the update, but the website is down right now, and I wasn't able to get the update to it. So here is an older model of Pluto. Now, Pluto is now classified as a dwarf planet, and that's... Mom, I know you brought this up because you love hearing me struggle over this. I agree with the need for a new classification. Basically what happened is, we discovered Pluto in the 1920s, found this new planet out past Neptune, all was great. But then in the early 2000s, we started finding more things like Pluto. And so the debate ended up becoming, do we call all of these things planets? Or do we come up with a new category for things that are like Pluto? And that's what they decided to do. And that's where the term or the category of dwarf planet came from. And this is actually not the first time that this has happened. In fact, when the asteroid belt was first discovered, what happened was the very first asteroid in the asteroid belt was found, the largest one, Ceres, and it got called a minor planet. Because it was kind of where people expected a planet to be. It was smaller, so they called it a minor planet. But then as we started finding more and more things in that region and seeing how small they were, we reclassified them to asteroids. So this reclassification of Pluto is not the first time that this has happened for objects in our solar system. So I'm getting, yeah,
We've
go ahead.
gotten two comments. One, somebody said, I thought Pluto was gray.
So you've probably seen the black and white images, but Pluto does actually have a reddish tinge to it, which is something we weren't fully expecting and are still trying to figure out exactly where that reddish tinge comes from.
And then we have another question. Could we also visit Maki Maki or Make Make?
Let me see if we have it in here.
Yeah, isn't Pluto like almost like a maroon?
Yeah, it's really, really reddish.
It reminds me of, and this is just nerdy, but the planet that the like rebel base was on in Star Wars: The Last Jedi.
Yeah, you're talking to me.
Yeah.
For those who don't know, I am not a Star Wars fan. It's a shameful comment that I make as an astronomer. But if any of you know what he's talking about, there you go.
It's Crate is the planet.
So this is Maki Maki. We don't have great images visualization, so this is a best kind of artist rendition of what it would look like. But like Pluto, it is also a really big chunk of ice. But this is another one of the dwarf planets that we have found. There are 5 in total. Pluto is one, Maki Maki is another. Then we also have Eris, Haumea, and then the 5th is Ceres, which is actually an asteroid, the largest asteroid in the asteroid belt, and the only asteroid to be classified as a dwarf planet because of how big it is. But the other 4, Pluto, Haumea, Maki Maki, and Eris, all are out in the outer solar system past Neptune. All right. Let's make our way back home.
And we just got a question from Amanda. It will be available after you're done. So yep, you can watch this tomorrow.
Yes, all of our streams, today's included, can be found on the video section of our Facebook page. They also are uploaded to our YouTube page, so you can find all of those there. And let me try and get this back working. There we go. All right. So yeah, there we go. Our not so brief tour of the solar system. There are still a lot of great things to see. I only touched on a couple of the moons, but we do have an entire show on just moons of the solar system that we have done in the past and that I'm sure we will do again. Probably actually November, we'll do that one. Or it is November, December. We'll do it in a couple weeks. So if you have any other questions for us, let us know right now. We can take a few more questions before we end for the night. And while we wait and see if any more of those come in, let me tell you what our next week is going to look like. So on Wednesday, we are doing another edition of Ask an Astronomer, where you can ask us any of your astronomy questions, and we will do our very best to answer them for you. In particular, we'll also want to talk about the launch that's happening. It was supposed to happen tonight, but got pushed off to tomorrow. But NASA and SpaceX are launching Dragon Crew 1 to send 4 astronauts up to the International Space Station. The second launch of humans from using SpaceX rockets and technology from American soil in many, many, many years. So it's very exciting to see this happening. We will be sharing the live stream with that on our social media tomorrow, right, Eli? You'll be sharing that. The launch is supposed to happen around 6:27 Central Time.
And the live stream starts at 2:15, so I'll share it around then.
Yeah, so it's going to be very exciting. I think they said weather's looking 70% favorable.
Yep.
But we will kind of summarize and update everyone on that Wednesday during Ask an Astronomer. And then next Saturday, Lindsay is going to be telling us all about the history of spaceflight and taking us through some of the amazing women who helped to launch us off of the Earth and explore the universe. There are some great people that were involved that don't get the notoriety, that don't get the attention, we'll say, that they deserve. Last thing I want to add is we are still selling our solar distancing t-shirts to help raise money since we have been closed since the middle of March. If you love what you're doing and want to support us, we definitely encourage you to buy one of these awesome t-shirts. We have options if you're in the Duluth area to come pick it up from the planetarium, or we can also ship it to you for a small additional charge. But with that, let's see, do we have more questions?
Yeah, we had a couple, and I'm trying to research them piece by piece. The first one is, how hot is the sun?
Ooh, good question. So the surface of the sun is about 10,000 degrees Fahrenheit.
Yeah.
The center is like trillions of degrees. It's hotter than, honestly, I can fathom. But yeah.
The next one is, what meteor shower just happened near Orion? I saw fireballs early morning. The Leonids is going on right now, I think.
Yes, I think it's the Leonids that are happening right now.
That's not super close to Orion, but kind of in the same
Well,
area.
We have the Taurids are also happening.
Oh, yeah, that's right. Yep.
And the Taurids are known for producing fireballs.
Right next to Orion, yeah.
Yeah, so it was probably the Taurids. I think the southern Taurids is happening right now.
Yep, that
And
sounds
then in a couple of weeks, the northern Taurids will peak. Or maybe I have that backwards. I don't know. But it was probably the Taurids.
And then the last one is how storms start and end on Neptune.
So it's probably a lot like storms here on Earth. You have just these winds moving in different directions, and when winds move in different directions, they can start air between them to circulate, and that can create these storm features that we see.
So touching back on the meteor shower, just followed up with another question. It was between the belt of Orion and a really bright star next to it. Yeah, that's the northern Taurids, which is going on right now, which peaked 2 nights ago, I think. And that's the meteor shower that's going on right now. So then there will be another one around there again, not too long from now.
Mm-hmm. And the Taurids, so we did talk about this in the What's Up November edition. Mm-hmm. So if you are interested in hearing a little bit more about that, you can always go watch that video from a couple weeks ago.
Yep.
We try to do that at the beginning of the month, always kind of touch on the things that are coming up that month.
Yeah. And then are the Leonids already peaking, or are they peaking soon?
I wish I could tell you. I don't know.
I have Google at my disposal.
I don't know the dates of the meteor showers unless I look them up.
Yeah, peaks early next week. So okay. November 16 to 17. No, I'm not going to disable ad blocker. Thank you. November 16th and 17th. And I don't know if this sounds kind of insane, but it's one of the most intense meteor showers, and it can be responsible for rates as high as 50,000 an hour. That is insane. I feel like that's not true.
That seems dubious.
But I'm also on space.com, which I feel like is reputable.
Yeah. Did I talk about the Leonids?
That seems like a lot. On What's Up?
Yeah. I can't remember. We've had so much happen between now and then.
50,000 sounds not right.
No, that doesn't sound right.
But regardless, November 16th and 17th, the Leonids peaks.
Yes. So lots of cool things to go see. All right, well, I think we will call it there. I think we've got the questions.
Mm-hmm.
Oh, nope, just got another one come in.
How would you see that meteor shower? Just so if it's like the Taurids, just look around the constellation of Taurus, and you'll see them. So like Taurus is what's it called? The radiant is the point where
Yeah.
they appear to come from. So you'll just see like a bunch of streaks coming from around Taurus. So like one of the apps that we recommend, I use one called Sky Guide on my phone. But on your phone, just look up like Night Sky app, and then go outside, type in Taurus, and then like hold your phone up and it'll show you where the constellation is, and just watch that area while it's dark enough and you'll see little streaks coming by.
And most of the time, meteor showers are best. You have the highest number of meteors per hour if you watch after midnight.
Yeah.
For the Taurids in particular, I think it's like 5 a.m. when they're supposed to get the
Really?
highest.
Whoa.
Yeah, it's pretty early in the morning. But the Leonids are after midnight. And if you can't tell, the meteor showers are named after the constellation that the meteors appear to come from. So the Taurids look like they're coming from Taurus, the Leonids look like they're coming from Leo.
Yeah. So just look around in that general area. And also, like, there's a lot of accessible information online. Just look up like Northern Taurids, and you'll be able to find a pretty good guide at
Yeah.
how to find it.
And if you're in the Duluth area or northern Minnesota area, you can also check out Astro Bob, which is the blog written by Bob King. He also does a really great job of keeping people up to date on things that you can see in the sky up here in northern Minnesota. So I think that's it.
I
I'm not
just
seeing
linked I just linked Astro Bob in the chat. So if you
nice.
want to check out his articles, definitely give him a look. They're
Yeah,
great.
he's awesome. We love Bob.
Mhm.
All right. Well, thank you everyone so much for joining us. You had some amazing questions for us.
Yeah,
It was a lot
truly.
of fun. Keep thinking of them so that you can come back on Wednesday and ask us some more questions because that's what we'll be doing. But we hope you have a wonderful rest of your evening, wonderful weekend, and we will see you next week. Bye, everyone.